Hi.
Hello.
Hi. How are you guys? How are you, Eva?
I'm good. How are you?
I'm good. Okay. So let's just wait for the others to join. We'll start in a few minutes, okay? Okay, so today we will learn about moles. So some of you have taken chemistry class before and some of you haven't. So it will be like a really, a simple class. Okay, where those who have taken chemistry class before, it will be like kind of just a review, simple review. And those who haven't, this is gonna be a new stuff for you guys. Okay. So I want everyone to participate. The way how this is going to work is whatever I'm writing on the screen, I want you guys to write it down on your notes, and I'm gonna do, I'm gonna do some questions, and I'm going to be just like calling people. Like I'll just call anyone's name randomly, and just to make sure I'm gonna ask question, and it's gonna be in random way. So make sure just follow with every steps through the process, okay? Pay attention, and if somehow you are confused along the way, just ask me, okay? So let's start. So first we're gonna go over what is mole. So what is mole? Anyone? Probably those who have taken chemistry before, they probably know. So anyone? Oh, okay, so mole. Yes, second.
A mole is a unit for measuring like the quantity of something.
Yes, yes. It's kind of like not exactly, but somewhere true. But so for example, a mole is just a word, right? That denotes a number. Like a dozen. What is a dozen? A dozen is 12. So mole is also same thing, right? It's a word, denotes a number, but the number's very big. Do anyone know what's the number?
Six
It's like
point zero two two one four times 10 to the power of 23.
Yes, 6.02 times 10 to the power of 23rd. Okay. This is and we do have a name for this number. So it's so special. They even give a name to it. So what's the name of this number? Anyone?
Avogadro's number.
Yes, this is your Avogadro's number. Good job. Okay. So we learn what is mole, and we learn what's the number of the mole, right? And the name of it. Okay, next what we're gonna learn is we're gonna learn how to calculate molar mass. Super simple, okay? So you want to pull up a periodic table. Mine is a bit blurry though, but that's gonna work. So you're gonna pull a periodic table, and on the periodic table, right, if you zoom into one element, so for example, if I want to zoom to copper, right? You can see I have two numbers. One is 29, the other is 63.55. Okay, so the one which is the lower, now don't think about, it's on the left, that's why that's the atomic number. It's on the right, it's on the bottom. Do not think about the position. I'm saying you're gonna go and compare which number is smaller. The smaller number will become your atomic number. That is your atomic number. And the bigger number is your atomic mass. Okay, so you always choose the bigger number as your atomic mass. Okay, so for example, if we look at cadmium, we have 48 and 112.41. So 112.41 will be our atomic mass. Okay, while 48 is the atomic number, which we don't care for now. The atomic number, we want to be able to find the molar mass. So we need to focus on the bigger one, the bigger number, the larger number. Okay, so now, for example, now we know which number to look for in the periodic table. Now, let's say I have water, H2O, right? And I want to find my molar mass of H2O. So what will I do? First, I have to break into like, what are the elements I have in this compound? So I have hydrogen and I have oxygen. How many hydrogens do I have? Anyone? Aditri. How many hydrogens do I have, Aditri?
2.
Yes. And how many oxygens do I have?
1.
Gia. Oh, yeah. 1. So first, you're going to take the compound, you're going to break into like, gonna categorize into what are the elements, and then gonna write, oh, I have 2 hydrogens, 1 oxygens, and then you're gonna multiply with their molar mass. So for hydrogen, the molar mass will be, which one? 1 or 1.0080? Which one will be the molar mass? Anyone?
1.008.
Yes, because it's the bigger number, right? It seems like, for those who have taken chemistry, it seems like, oh my God, this is so simple. Yes, it is. The real EpiChem stuff. Well, this is actually the first unit of EpiChem. This is the first unit of EpiChem 1.1. So EpiChem is like, some students have previously they have taken honors chem, but there's a lot of students who just jump into EpiChem. So that's normal too. That's why they started with a very basic stuff. So that's what we're gonna do in this week bootcamp, is to go over the conversion, the stoichiometry, which gonna be the hardest one. And I would recommend all of you to take at least 2 classes of stoichiometry. And then next, after the molar mass conversion, we're gonna do balancing first before we jump into the stoichiometry. Okay. And then, okay, let's continue this one. So oxygen, the molar mass of oxygen would be the bigger number, so 15.999. You're going to take 15.999. And then you multiply it and add it up. You're going to get, let me just do it real quick. Two times 1.008 plus 15.999, you're gonna get around 18.015. Okay, question. What is the unit of molar mass? Anyone? Anyone want to volunteer? Yes?
Grams per mole.
Yeah. You have taken honors chem, don't you? Second?
Yeah, I have.
Okay, that's good. Okay, so yeah, it will be grams per mole. Okay, it will be grams per mole. Okay, super simple, right? This is how we count molar mass. Now I'm gonna give you this periodic table in front, and I am going to ask you to find the molar mass of CO2. Okay, so you need to find the molar mass of CO2, and once you have all of you though, okay, once you have the molar mass, make sure to send it to me, text me on the chat, okay? Personally, not in the public chat. So try to do this. First, again, recap. What are the elements, how many they are, multiply with their molar mass, and then add them up. Okay, super simple. So try to find the molar mass of CO2 and yeah, text me. Good job, Saket. Good job, Aditri. Good job, Vanessa. Good job, Udayan. Good job, Rebecca. Good job, Ria. And I really like the way like most of you put the units, because whatever in chemistry, everything needs to have units. Okay, so make sure you don't just like put a number, because if I say, oh, I have just, I have 5, you have 5 what, right? You need the units. Good job, Gia. Good job, Vedika. Okay, now let's make it, your groups are super fast. So, okay, let's make it a bit difficult or challenging. Okay, so let's try this one. Al, wait, let me just check. Actually, let's try Mg 3 PO4 2. Let's try this one. Okay, so for this one, what do you do? Let me start asking question. Rebecca, how many Mg's do we have here?
3.
Good job. Ria, how many P do we have? How many phosphorus do we have? See, we have the 2 outside, right? The 2 outside means it's going to be distributed inside the parentheses. Okay, it's going to be distributed inside the parentheses. So how many P's do we have? Ria.
Sorry, can you hear me now?
Yes. Yes,
Okay.
you're
2.
okay. Yes. And then how many oxygen do we have, Ronaf?
8.
Yes, we have 8 oxygens. Now, everyone's already know how many elements each are. So make sure to just do the math and find the molar mass and send it to the text. Good job, Udayan. Good job, Sakit. Good job, Sahana. Good job, Gia. Good job, Vanessa. Okay. Okay. Good job, Eva. Good job, Ria. Good job, Rebecca and Aditri. Good job, you all. Okay, awesome. So now that we have learned how to calculate the molar mass, now we're going to go to our conversion, okay? So whenever you are going to convert from grams to moles or vice versa, that means from moles to grams, right? What are the things you're going to need for this conversion? What do you need for this conversion? Anyone?
You need the molar mass.
Yes, we need the molar mass. That's why we just learned how to calculate molar mass, okay? You need the molar mass. So for example, okay, so the way I like to do my conversion, whatever, because there is something known as dimensional analysis that we're gonna do now. And for the dimensional analysis, you need to have a relation, okay? You need to have relation. So the relation, whenever you count a molar mass, once you count it, if you're a beginner, make sure you just, write it down. Maybe after a while, you don't have to write it down. Maybe after a month of doing this, you don't even need to write it down. But for now, because it's in the beginning, just like, just write down 1 mole equals to whatever the molar mass that you counted, okay? So this is gonna be replaced by a number, the mm is gonna be replaced by a number, and the unit of that gonna be in grams. Okay, so this is very important. This relation is very important. You have 1 mole and the molar mass and the unit of the molar mass. This is going to be replaced again by a number. It's going to be grams. So for example, if I want to do, if I want to do the relation between mole and grams of Mg3PO4 2. or magnesium phosphate. So what I'm going to do, 1 mole equals to 262.853 grams. That's going to be my relation. The relation is something that you will have to create yourself. Okay, it's not going to be given to you. Now, let's say they give us question, okay? Find the mass of 2.50 moles of magnesium phosphate, Mg3PO42. Now, what we will do, now this is, for those who this is still new, please pay attention to this. This is very important. This is what you're gonna keep using in chemistry every time. Not just the method is more important rather than the conversion itself. But yeah, this is the dimensional. We start with whatever given to us, which is 2.50 moles of magnesium phosphate. You always start with whatever that is given to you. You always start with whatever that is given to you. Okay? Once you have that, what do you do? Once you have that, now you have to choose from your relation that you just made before. What is going to go on the bottom and what is going to go on the top. Okay, that's what you're going to choose. Because you have mole here, so what's going to go on the bottom? The mole. Why? Because you want to cancel it, right? Yeah. Good job, Sakit. So because we have mole here, who's going to go on the bottom? The mole. So you're going to take this part, not just the unit, but the number as well, which is 1. So you're going to take 1 mole and put it on the bottom. Okay. And opposite to this, because this is an equation, you can just take 1 and just leave it the other stuff. So the rest of it, which is the right-hand side, you're going to put it on the top. You're going to have 262.853 grams. Okay. And also you do want to mention the type of compound or element that is. And that's it. And then you can calculate. How do you calculate? You just, anything on the top you multiply, on the bottom you divide. It's like a fraction, okay? So think about this is like a fraction, this is like a multiplication. Okay, so 2.5 times 262.853, that is going to give us 657. See, look at this, okay, how the moles and the moles cancel out. right? So our leftover unit is what? Grams of magnesium phosphate. Make sense? I think it does make sense, right? Okay. Now let's just try another one, okay? Question. Okay. Write down the question. Oh. Okay, Vedika, how do we start?
The molar mass of NaNO3.
Yes, we find the molar mass of NaNO3. So, okay, can you guys find the molar mass of NaNO3? And then I'm just gonna call by name, whoever I call, like, will need to answer my question, okay? Vanessa. So what is the molar mass of NaNO3? If you haven't got it yet, that's okay. Take your time.
I got 84.994 grams per
Good
mole.
job. Now, what is the relation? What is our relation now?
1 mole.
I mean, 1 mole
1 mole
equals
is
to?
85 if you round it.
Yes, good job. Grams, right? Oh, do not forget the grams, okay? Now, Udayan, tell me, once we have this, how do we start our dimensional analysis or our table?
You would put 84.994 on like the left, upper left of the table. Or
That's okay. That's okay. So we always start with whatever that is given to us. Okay.
oh, you put that on the left, and then
Yeah, we start with
85
that.
on the right,
And then 85 where?
on the right, upper right.
Yeah, that's right. But let's see why we do it. So we're gonna start with 7.55 moles of NaNO3. Now to to identify who's gonna go where, the first thing you need to know, always put whatever they give you first. Okay. Next, to know, what do I put here? What do I put here? I would recommend you to first figure out what to put on the bottom here. Okay, whatever you need to put on the bottom gonna comes from this unit. So if you have moles here, you're gonna choose which one has the mole, and that is the part you're gonna put on the bottom side or denominator side. So you have the moles, right? So which one you're gonna put, the 1 mole or 85 gram on the bottom?
Or the 1 mole.
Yes, because you have moles here and you want to cancel it. So you're gonna put 1 mole of NaNO3 on the bottom, and opposite to that, which is 85 grams, you're gonna put on the top. Okay, and that's it. And doing that, we're gonna get 641. Oh, you can just round it off to 42 grams of NaNO3. Does anyone have a question? Like, if you're shy, you can just also just text me.
Could you please explain how you got the 642 or 6.42?
Yes, sure. So it's like a fraction, this one, okay? Instead of doing this, you can also do 7.55 moles of NaNO3 times 1 mole and 85. grams. So what do? When you have this, what do? You take the number here, you multiply that with this one, and you divide with this one, right? So we take 7.55, multiply with 85, divided by 1. We got 641.75, and I round it off to 642 grams. Does it answer your question? Okay. Any other question? No question is silly. Every question matters. So if anyone has any question, just ask. No? Okay. So if there is no question, I'm going to do the next one, which is just a little bit different. Okay. I want everyone to start working on this. Okay, step by step. What do you do first? Relation, and then once you have your relation, how do you start? And once you started, how do you decide what do you put on the bottom? Then what do you put on the top? And then do the calculation. Okay, do it step by step. And then I'm just gonna like call anyone's name. Okay, Aditri, how do we start?
Find the molar mass.
Yes. So have you found the molar mass?
I got 44.009 grams per mole.
Good job. So once you start with finding the molar mass, what do you have to do after that? You need to establish your
Given or known.
relation,
Oh.
right? What was the relation?
1 mole equals 44.009.
Good job. Okay, good. Now, Eva, what do we do next?
Next, you would set up the equation and
Mhm.
you would start with writing 85.4 grams of CO2.
Good job. That's okay now.
Okay.
I know you are able to answer it. That's that other answer. Okay, thank you. Okay, Gia. Now what do we do next?
Now we put the amount of grams on the upper left, so 85.4. Sorry.
Ooh, who do we choose first? Do we choose what to put on the top or on the bottom?
Oh, on the bottom. So it's
Ha.
1 mole.
So, how do we choose? Now, listen to my question, okay? You'll get to the answer by yourself, okay? Listen to my question. You said, oh, okay, we choose the bottom one first. And how do we choose what goes to the bottom? Based on what? Based on here, whatever this is. So on this side, it's grams. So who's gonna go on the bottom?
grams.
Grams. And what's the number?
4.009 grams.
Yes. Does it make sense?
Yes.
Right? Because it's trying to cancel the units. Okay? It does not have fixed position. What is fixed, it's what you're going to start with. That's the first, like the only thing that is fixed. And then you are like just playing, just playing puzzle. Oh, I have grams here. I'm going to put grams here so I can cancel it. Okay? So I'm going to put that much of gram CO2. Now, Rebecca, what do I put on the top?
1 mole.
1 mole of CO2. Good job. Okay, now do the math and yeah, text me the answer. Those who already know what is significant figure, make sure you make your answer to the correct significant figure. Okay, and those who haven't, that's okay. We're gonna like, when we're doing the full program, we're gonna cover the significant figure there as well. But for now, let's just like focus on the mathematical part, okay? So yeah, just text me the answer. Okay, Vedika, the number's right, but look at this. What unit you're gonna be left off? So the grams of CO2 gonna cancel out like that, right? So what is the unit you're gonna left with? Mole of CO2. So whatever number you have, the unit will be mole of CO2. Good job, Ronav. Good job, Aditri. Good job, Rebecca. Okay, I think everyone got it. Good job. Okay. Now, this is the first relation I introduced you guys with, right? The 1 mole equals to molar mass gram. But there is more, okay? There is more with the moles. There's actually 3. The second one that I would introduce would be regarding 1 mole equals to the Avogadro's number, which is 6.02 times 10 to the power of 23rd. And these can have either atoms or molecules or ions. We're gonna learn about what are the atoms, molecules, ions in like on other day, okay? But for now, just make sure whenever you see these words or formula units, okay? Formula units. Whenever you see this words, that means you have to use this relation. If you see grams, then you have to use the molar mass relation. So you have 2 relations now. You have 1 mole equals to 6.02 times 10 to the power of 23rd. And you also have 1 mole equals to whatever the molar mass, and the unit will be the gram. Okay, so let's start. Okay, write down the question. Everyone try to start. Sahana.
Yeah.
What do we start with?
The 4.23 moles of H2O.
Good job. Sakit. What do we put? Okay, before that, which relation do we choose? The first one or the second one? The first one with the Avogadro's number or the second one with the molar mass? And why do we choose what we choose? Sakit. Wait, is that how to pronounce your name?
Oh yeah, here, sorry.
Sorry. Yeah, go
No,
ahead.
that's fine. You use the mole as Avogadro's number
Yes, we're gonna use this one, right? And why do we use this one, not the molar mass one?
because we have to find the amount of molecules.
Yes, we have to find the amount of molecules, not the mass. So we don't need this one yet. Probably not in this question. Okay, good job, Sakit. Now, Ronaf, now that we know we have to choose this equation, right? What do we put on the bottom?
Avogadro's number?
What do you, okay, let's try again, okay? Now, to know what to put here, you have to look where? Because in this equation, you have two parts, right? One part is the mole part, the other part is either one of this. Because we're talking about molecules, so you want to just focus on the molecule part. So on one part, you have moles, the other part, you have molecules, right? To
Yeah.
choose what to put on the bottom side, you have to look at what on this side.
Yeah.
So what do you put on the bottom and why?
1 mole, because then it'll cancel out.
Yes. So we're gonna put 1 mole on the bottom so we can cancel them out. So of course you want to add the water. And then what do we put on the top, Ria?
You put the molar mass of water, H2O.
But why would we put the molar mass of water? Okay, look at this, okay? Because you choose the 1 mole, right? Well, okay, Ria, what are we finding? What's the question asking you for?
The number of molecules.
So the number of molecules, is that in the first equation or in the second equation?
The first equation.
The first equation. So we put the 1 mole, right? If they're asking you for molecules, are you gonna put the molar mass here, which is very unrelated, or are you going to put the Avogadro's number?
The Avogadro's number.
Yeah, does it clear your confusion that it shouldn't be molar mass here?
Yeah.
When would it be molar mass? If they're asking you for grams or the mass, but they're asking you for molecules, so you have to pay attention to the question, what they are asking you. So we're gonna put this number on the top. Molecules of water. And then find the number. And we get 2.55 times 10 to the power of 24th molecules. The unit's very important. See, the moles of water cancel out. We have molecules of water. Okay. Okay. Any question? I mean, like, just shoot me with any question. No question is too silly or doesn't matter. So just ask me if anyone has any question. If you're kind of shy, just text me the question. Like if there is any part of this that still doesn't make sense, like why did we put the Avogadro's number on the top? Why it's not on the bottom? Why it's not the molar mass? Anyone? I guess that's fine then. Okay, let's try another one. Okay, start this. I wonder if I skip anyone. I mean, like, I wonder if I didn't ask any one question. It's like randomly calling names. Okay, start whatever you can. Okay, make sure you know which equation to choose. So I'm just gonna write it down here. 1 mole is 6.02 times 10 to the power 23rd atoms, molecules, ion, formula units, blah, blah, blah. And then the next one was the molar mass 1. 1 mole is equals to molar mass, and the unit will be gram. Okay. Udayan. How do we start? Again, the same thing. It's just like, repeating again and again and again.
Start with 7.34 times 10 to the 23rd.
Yes. Oh, well, good job, Saket. That's really fast. But we'll see whether that's, that is right. Okay, but yeah, we start with that 7.34 times 10 to the power of 23rd atoms of magnesium. Okay, and then now, who have it? Okay, Gia. What do we put on the bottom?
On the bottom, would you put,
Look at the, okay, see, you need to ask yourself question, okay? What do I put on the bottom? What do I need to look to confirm what to put on the bottom?
the
Ask
atom?
the atom. So what's the number in front of the atom?
7.34 times 10 to the power 23.
No, that's what you already started with. I mean, like from the relation,
Oh. 6.02 times 10 to the power 23.
Yes. Atoms. Okay. See, that's all. You have to ask yourself question. You cannot just like, I don't remember. Ask yourself the right question. That's epichemistry. You need to know how to think. Okay. And this is like still the easy stuff, like easiest stuff. And then as we go into the program, you'll see like, or into the class, you'll see like how hard, like how much, analytical power they need to just like, for the epichemistry. So yeah, so we put that on the bottom. Opposite to that, which is the 1 mole, we're gonna put it on the top. So atoms of magnesium. I'll just like, okay. And okay, now this is somewhere some students always get mistaken doing the calculation. What happened is that they do the calculation, they're gonna start dividing, but then once they divide by 6.02 times 10 to the power 23rd, and then it's not gonna give you the right answer unless you put a parenthesis. So make sure whenever you multiply this with 1 and then you start dividing, put a parenthesis. Your calculator wouldn't understand that this multiplication actually on the denominator side if you don't put the parenthesis. Okay, they would think it's on the top. So make sure you put the parenthesis, okay? And then, yeah, put the numbers in. This group is really fast. I think probably most of you already taken some kind of chemistry, that's why. So we have 1.22 moles of magnesium. Again, whenever you're going to put the answer, make sure you put the unit and what type. Okay, because we're gonna learn in our third lesson, stoichiometry, where we're gonna try to convert one type to another type. So make sure always put the unit and the type. Okay. Good job, Vedika. Good job, Ria. Any question? Whoever has question can ask, okay? This is a safe place. Now, make sense everything? Okay. Now now what we're gonna do is we're gonna do 2 steps conversion. Okay, we're gonna do 2 steps conversion. Okay, let me just like write down the question first. Okay, so that's the question. So second, if you're able to do this, try this on your own, okay? Yeah, whoever they feel like they can do, just do it, and then just put your answer to the chat. Okay, so how we would do this is, look at this. Again, we start with our relation. How do we know what relation to use? You're just gonna put all relation you know. So first is the Avogadro's relation, in which you have 1 mole equals to Avogadro's number. And then this is gonna be atoms, molecules, or whatever, okay? I'm just gonna put atoms here because in this question there's atoms. And then the second one, we're gonna write down the molar mass equation. Now, okay. Now what are we going to start with? Again, I did 3. What are we going to start with?
You have to start the formula by writing the given.
Good, which is,
54.3 grams of calcium.
yeah, good job. So I am sorry if I keep repeating the same person again and again. I'm trying to be very random as possible, or I'm sorry if I don't call anyone's, like I left out anyone's name. Okay, okay, good job, Aditi. Now next, Eva. Which equation are we going to choose? The first one or the second one?
The second one,
Good. Why?
because we have to convert grams to moles first.
Yes, because we are provided with grams. That means on this bottom, we have to put the grams. And the second one is the one that has the grams. So instead of you have to convert this into the molar mass of calcium. So we can go back to the periodic table above and find the molar mass of calcium, which will be somewhere 40.08. Okay, so I'm going to take that. Gonna put, wait. Yep. So we're gonna take so instead of we're gonna put 40 here. Now, Gia, what do we put on the bottom? What do we put on the top?
On the bottom, we're gonna put the grams, so 40 grams.
Good job. Of calcium. And on the top?
On the top, we're gonna put
Opposite of the gram. Yes, opposite to the gram, which is
1 mole.
1 mole. Make sure to put the calcium. Good job. Now, Rebecca, are we done?
No,
Why not?
because you need to find the number of atoms, and right now you only have the moles.
Good job. Yes. Ria, what is the next process or next step?
You have to put the moles on the bottom to cancel them out. And then on the top, you have to put Avogadro's number to get the atoms.
Yes. So the next step would be choosing the first equation. You're right. Choosing the first equation. Why? Because we want to find the atoms, and the atoms is in the first equation. And then because we have the mole, right? We're gonna choose this one. We're gonna put on the bottom now. And then this one will go to the top. Good job, you all. And then you can calculate the answer. Good job, Eva. Saket, what happened there?
Sorry, that's not the correct answer.
Oh, that's okay. I mean, like, I know that's not the correct answer, but like, what mistake did you do? Like, what happened there? Like,
So I just multiplied because I was just going too fast, I feel like.
oh, that's fine. That's okay. That's okay. Okay, good job. Good job, Ronaf. Good job, Sahana. My God, most of you have taken chemistry, right? Good job, Rebecca. Good job, Aditri. Good job, Gia. Okay, so because most of you already taken chemistry, is there any part, you probably already done this in your chemistry class, so is there any part from your previous chemistry class regarding this topic, of course, this topic, that doesn't make sense? Not the stoichiometry part, that's gonna be on our third class. I'm talking about this, especially this thing, where you convert grams to moles, atoms to molecules and stuff. Now, maybe some of you might ask, what's the difference between atoms and molecules? Anyone volunteer? What's the difference between atoms and molecules? And, oh, yeah, atoms and molecules.
Atoms
Yep.
are well, molecules are arrangements of atoms.
Yes, it's a multiple of atoms, right? Like when you have more than one atoms, that's called molecules. And when you only have one atom, that's one atom. Okay, good. Now, what's the difference between formula unit? Now, this is important for epi chemistry, okay? Because the terminology is really important. You cannot mix them up. So what is formula unit versus molecules? Anyone who has taken chemistry before? Or who has even, like, I know some in honors chemistry, some of them did not even, like, mention. So this is probably very new. Formula units, what is it? Right? So formula units, kind of same as molecules, but it is for ionic compound. Okay, so for example, if you have NaCl, which is an ionic compound, you would say, I have 6.5. Let's just say this is the amount, okay? You are not going to say, I have 6.5 times 10 to the power 23rd molecules of NaCl. No, you're going to say formula units of NaCl. Why? Because it's ionic compound. Now, for those who don't know what is ionic compound and how do we even know why NaCl is ionic compound, don't worry about it. We're going to go over that in unit 2. So that's fine. Okay, but those who already know what is molecules, right? What is ionic versus covalent, for the compound that is made from ionic bonding, metal and non-metal, that's gonna be called as formula unit rather than molecules. Okay, make sense? So if I have 8.9 times 10 to the power of 15 X magnesium, what is this gonna be? It can be answer choice A, atoms, and answer choice B, ions, C, molecules, D, formula unit. What will be the answer?
Atoms.
Atoms, because this is just one type of atom, or just one atom, sorry, not type. Now, if I change this into O2, this is gonna be? Other than Sakit, anyone?
Molecules.
Molecules, good. If I change this into CO2, what this gonna be? It is still molecules, right? Because those who already know, that's fine, okay? And then what if we have MgCl2? What's this gonna be? Those who doesn't know what is ionic compound versus covalent compound, that's fine. If you're kind of like, what is this? That's okay. We're gonna go over this later on, during like when our full syllabus gonna start, okay? But this is just for those who already taken chemistry before they know what is covalent and ionic compound. So if we have MgCl2, what is gonna be?
Formula units.
Formula units. Yes. Okay. I think everything went really well. Anyone has any question? You can text me the question. Okay, if you feel shy to ask, but I don't think there is any reason to feel shy. I have seen students who are, they started from like they never take chemistry ever before and still got a 5. And I have seen students who taken honors chemistry and still got a 4. So this is your starting point. Okay, yes, your starting point might be different. Everyone might have different starting point, but it depends on how hard you're gonna work. Okay, and how sincere your work is. But overall, I feel like I really feel good about this class today. Everyone participate and everything went very well. And good job. I think everyone understand, right? There is no question. Okay, then. Awesome. So I've posted the questions, assignments into the Google Classroom as well as the Discord. So whoever that hasn't joined the Google Classroom, if you don't want to join the Discord, that's fine. The Discord is for, if you want to, ask a question, something like that. But you need to join the Google Classroom to see the recording of the lesson as well as the assignment. Okay, awesome, guys.
Wait,
So-
I have a question.
Yes,
What
go ahead.
exactly is the code for the Google Classroom?
What's the what? I'm sorry.
The code for the Google Classroom.
Can you type it? Your question?
Okay.
Oh, the code of the Google Class. Let me check. Sorry. I already sent the link to the but I'll still copy it. Okay, I'm gonna put it on the main chat. Okay. And the code is this one. Okay. So yeah, any other question?
Yeah. How about the Discord?
The Discord. Have you received the email, Saket? No?
Sure.
No, that's okay. Where did you get the Zoom link then? It was in the email. In
Oh,
the
wait, no, I
email,
did get it.
right? So everything's there, okay? You'll have the Google
Yeah.
Classroom link, the Discord link as well, okay? Okay, awesome. Any other question from anyone? No? Okay, then I'll see you next. I don't think any one of you have to repeat this class, but if anyone feel like left behind and want to repeat, we still have a class tomorrow regarding the same thing. If they want to do some extra practice, we have tomorrow at 10 a.m. Okay, so if you want to join, you are very welcome to. Okay, awesome. So yeah, bye-bye.
Thank you.
Thank you.
Okay.